This is example 5.3.8. It says which one of these cars is more massive, and it gives you some data, or excuse me, the plot of two different experimental values, car A and car B, and it gives you the acceleration and the force value. So what you're going to do here is you're going to say, okay, I've got acceleration and I've got force right here. So if I were to calculate the slope of this graph, which would be rise over run for slope, that would give me acceleration, which is meters per second squared, divided by force, which is kilogram meter per second squared. So when you do this, when this cancels out, what you're left with is the slope is going to equal 1 over kilograms, which doesn't really make a whole lot of sense to do. So what we're going to do is we're going to go ahead and flip it instead, and we're going to do something called run over rise, which is the inverse of the slope. Okay, slope inverse. When I do that, what I'm going to get is I'm going to get kilogram meter per second squared over meter per second squared, which is going to give me kilograms. So in this case, it makes more sense to do run over rise. So I want more of a run and less of a rise. Whenever I do that, the one that has more run is the A term. The one that has less would be the B term. So I have a larger kilogram value, or a more mass, for A. Now you can actually do this. You can actually plug in experimental values into F equals ma. You can come to this point A, you can say, okay, what if I look at A and I have a force of 200 and I have an acceleration of 1? That would mean that the mass would have to be 200, because I'd have 200 and then mass and then 1. And then I could look at this point right here on B and I could say 200, 2. That means that my mass value would have to be less. It'd be 100. So there's lots of different ways of being able to solve this problem. You should be able to solve it even if there's not numbers here based solely on what's here. Now you do have to be careful, because sometimes they will put force on the y-axis and acceleration on the x. Although really it should be force on the x, because you're changing the force in the experiment. But that's another conversation.